the difference of earthquake and wind load. Pag earthquake, yung buong height ng story kino-consider natin kasi of course earthquake, the ground motion itself, doon nag-uumpisa yung earthquake, di ba? So it should be from the base. If you have 3 basement, then you have to start from the lowermost part of the building until the last level of the building. That's the difference between the seismic and the wind loads. While in wind loads, you need to consider the base of the building that is just above the ground surface or ground level. So we already did the seismic and wind loads automatically applied in the building. And we already did the superimposed dead load and the live load. So we are done with the loadings. Now, I want to show you also the different load combinations that we have. Basically, this software itself can create you load combinations by default. Okay, so that's the good thing about using this software. Magaling siya kasi kino-consider niya yung different load combinations. As far as I know, the load combinations that you can see from the NSCP 2015, it's also from the ASCE 705 or the ASCE itself. It's coming from that code. So yung code na nakikita nyo sa ating structural code sa NSCP, it's from there. And especially at this time, a few years from now, you will be using, or most of the designers in the Philippines will be using the spectral accelerations or the response spectral accelerations for the seismic design. So mababago na yung part ng ating load combinations when it comes to the seismic loadings. So from UBC 97, we will jump to ASCE, which is the reference code of the spectral acceleration. So yun na yung gagamitin natin in the near future. And I hope na kayo din pag in the future, pag designer na kayo, then you will be using that one as well. So magbabago yung ibang part ng ating load combination, especially with the earth. I'm referring to the earthquake part. But I will show you for now, the load combinations based on the default design combos coming from the codes. Okay, when you have this, let me go back para makabisado nyo. Go to define, and then you have here the load combination. Let's click this icon here. It has already created some because this is a previous model. But basically, wala yan, wala pa. So you go to define, load combination, then add default design combos. And then from there, you have editable, convert to use combinations. Editable means whenever you create load combinations, you can modify it, you can rename it. It depends on the codes that you want to use. Say, for example, the NSCP, you want to pattern it the way how they do it in the NSCP, then you can click this convert to user combinations. But careful, what type of design are you doing? Is it concrete frame design? Is it concrete shear wall design? Is it concrete slab design? So it depends kung ano yung i-design mo. For example, for us, we are just after this structure, we are just after the design of beam and columns. For the design of a slab, usually we do it in SAFE, not here in Etabs. But you can do it here as well kasi ngayon, yung bagong version ng Etabs is, ang ginagawa nila is they are trying to capture as well the ability of SAFE CSI to design a slab. Ang SAFE kasi is very specific for the design of slab kasi may mga options siya na wala sa Etabs, especially with the application of loads. So important doon is pwede kang mag-apply ng line loads that is running on the different part of the slab. Kahit wala yan sa beam or wala yan sa part ng division of slabs, it's okay to apply. Walang problema. Hindi mag-error yung model. But here in Etabs, you will find you will encounter error kapag pagdating sa application ng loads at wala sa linya. For example, wala sa biga, sometimes ayan, magkakaroon ka ng error dyan. So it's better to design beam, columns, and walls using Etabs, and then you jump to Safe CSI to design your slabs. So ang gagawin natin is concrete frame design. So you should select this concrete frame design here, and also pick this convert to user combination editable. Okay. When you're done, click OK. There you have it, the different load combinations. And from these load combinations, I want you to be familiar also with the different load combinations that we have in the Philippines. Right now, say for example, if you click this icon over here, you will find here 1.35 scale factor. Oh, this is not normal. Oh, this is not normal. Wait a minute, something is wrong. View revise over. Oh, see, naka-Eurocode pala tayo. Kaya pala. So careful, guys. You have to go here on design, concrete frame design, view revise preferences. Although this is by default, by your Etabs itself, naka-default siya sa ACI, so no worries. Kasi ginagamit ko lang ngayon is the Eurocode. That's why nakaset siya into Eurocode, but usually it should be set to ACI. Otherwise, iba yung makikreate doon na load combination. Let me double check again. It should be ACI 318. Click OK. So it should be ACI 318 tayo. So depende sa design na ginagamit nyo, doon magbe-base yung load combinations na makikreate. Okay? So it should be ACI 318. Okay, so let's go. Define load combination. We will define again. Wait a minute, add default combo. And then choose concrete frame design and concrete to user combinations editable. Okay. So how many load combinations we created? 1, 2, 3, 14. Okay, we have 14. Then let's check the UD or ultimate design con 1. Modify. Okay, so ito yung makikita nyo sa ating NSCP. Tama? That the dead load and live load should have a combination of 1.4. Okay? And then next, for the UD combination 2, dead load and live load should have a combination of 1.2 and 1.6. Tama? I think we have it from the NSCP. Sir Renato? Still there?
Yes, nasa nandun. Yan.
Oh, okay. Ito. This is the basic load combinations of the minimum design loads that we have in the NSCP. As I've said, it's also coming from the ASCE. That's why parehas yung pattern. The only difference is that we are using the UBC or the Unified Building Code when it comes to seismic, whereas in ASCE, they're using the response spectral accelerations. So, yun ang differences, but all are the same. Other than that, all the rest are the same. So here you have 1.4 of dead load, and then you have 1.2 of dead load plus 1.6 of live load. Actually, ito ay 1, 2, 3, 4, 5, 6, 7, and then plus 2 on earthquake. 8, 9. Oh, how many do we have? 1, 2, 3, 4. We have 40. Okay. Anyway, this is more complete. So UD1, you can see there 1.4 dead load. It's correct. UDCon 2, 1.2 and 1.6. This is correct. UDCon 3, this is 1.2, 1.2 for dead load. And then for live load, it's 1. And for wind load is 1. So ito na yung mga combinations. Different combinations na nakikita nyo dito. Combination of wind load, 1.2 of dead load. Okay? Kita nyo ba, guys? Kita? 1.0 of wind load. Okay ba? The good thing is, madali na lang siya kasi Yung software mismo is kaya na niyan i-produce tong mga. Just be careful kasi sometimes we do editing some of the other parts. Let's say for example this F1 here, which says that 1.0 for floors and places of public assembly for live loads in excess of 4.8 kilopascal and for garage live load or for other live loads. Ito yung sinasabi ko na reducible live loads. Pwedeng i-register, for example. Just following these provision of the codes, you will be on the safe side. Okay? So for example, wala tayong papalitan dyan. Kung gusto nyong palitan yung pangalan, you can rename it. How? Modify show combo and then dito for example, Renato. Pwedeng palitan ng Renato. But anyway, hindi na natin siya papalitan. UDCon 1, ano bang, paano ba tayo mag-move ng combination? Usually, ang nilalagay dito is 1.4 dead load. Ganyan ako mag-name para kakabisado ko kung anong laman. For example lang 1.4 dead load and then dito, i-rename ko to ng 1.2 dead load plus 1.6 live load. Yeah. And then the rest, you can rename it para alam nyo anong laman nitong load combination na to. So you can name it like that. So when you already have the different load combinations and I guess we already specified the diaphragm as well, which is important. Yan yung diaphragm natin. Diyan tatama yung ating lateral loads. And then ano pa ba? Define shell uniform mass source. We already specified the mass source. Ang mass source natin, this is we'll modify this. Special loads should be dead load plus SIDL add dead SIDL. Ano yung ating mass source before? Sa ating model, can anyone give me the specified load patterns? I think SIDL dead load, and then we can consider 0.5 of live loads. No, this is for seismic. This is for the mass source lang. Okay. Sir Renato, do you have the model, the previous model?
Wala.
Okay.
Na ano yung laptop ko, di ba?
Mass source. Mass source by default. Specified load patterns, dead and SIDL. The mass source should be the dead only, I think. I'm not sure about it. Dead. Click OK. Okay. So after that, wait a minute. You are presenting. How many minutes more? Sure na to?
Tapusin na lang yan. Malapit na.
Tapusin na lang to. Okay, anyway, after this, pwede na tayo mag-run. I hope pwede na tayo mag-run. Big lang. Bibilisan ko lang to sa bit lang, ha? Right. Okay. Give me 2 minutes. Okay. Let me go back again. Share your entire screen. Right. Define mass source. should be as ideal as well. Okay, so we have two mass source and specified load patterns. One is dead and the other one is as ideal. And lumps up and click OK. Ang gamit kasi ng mass source is especially for earthquakes, yun yung gagamitin for earthquake. Okay? So, anong part ng loadings natin ang masasali pagdating sa earthquake? Kasi in earthquake, we have different frequencies, vibrations. So, you have to specify what type of loadings na masasali sa earthquake. Okay? Importantly, in any case, hindi dapat pwedeng mag-act simultaneously ang wind load, earthquake, at earthquake. Okay? So, kailan ba bumagyo na lumilindol? So, maybe there will be, or there are some cases na lumilindol at bumabagyo, but it will never, hindi mataas yung probability. Tama ba? May nakarinig na ba kayo ng bumabagyo na lumilindol? Hindi naman, di ba? So you should never mix these two things, earthquake and seismic load. That's why there's no any combination at all na merong wind load and earthquake load. So part of loadings which will be included in the analysis of the seismic will be your mass. The mass of the building will come from your dead load and SIDL, of course. And sometimes we do consider part of the live loads. But for now, we are going to consider the dead load and SIDL. So we are done with the mass load patterns, load cases, load combinations. What more? Diaphragms. We also consider diaphragms. So sa analysis, let's check some of the important part here. Select degree of freedom. We are doing 3D analysis, so it should be 3D. Just in case you are doing plane analysis. For example, meron kayong beam, then that's going to be considered as plane by plane. So if you select this, by plane lang siya. If you select this, you're considering 3D model. Analyze. Aside from that, ano pa ba? Mesh, yeah. Importantly, may mesh na ba tayo sa slab? Let's check if we do have mesh. Shell analysis mesh. But we need to remove the diaphragm. Okay, meron na tayong mesh. No worries. May mesh na tayo sa slab. Maganda yung meshing natin. So you should do regular mesh. This is for the finite element analysis. It will, napaka-importante itong mesh kasi the finer your mesh, most probably it will capture the real behavior of the slab or real behavior of your elements during the different or when you show the different results when it comes to seismic and wind loads and of course gravity loads. Ano pa? Define wala tayong walls, so hindi natin i-consider yung mesh pagdating sa wall. Sa design preferences, later on, mamaya ba yun? Okay, so okay na tayo. When you're done, then you have to run the analysis. Okay, by clicking this icon here, it means you're going to run the analysis. Okay, if you click this, the models will be analyzed. It will take time. It depends on your computer. So may mga computer na medyo mabagal yung analysis. So depende sa capability ng ginagamit yun ng computer system. All right. So this is the behavior of our structure after running the analysis. This you can see here, this is the effect of gravity loads. You can start your animation here just to be able to check your structure. This is important as well. you can do your animation para makita nyo kung may mga lumilipad na mga biga. Anong ibig sabihin pag may mga lumilipad na mga biga? Which means yung connection ay hindi tama or hindi sila nagsasalubong. So, okay naman ang dead load natin. Makikita mo kasi dito may mga lumilipad-lipad na ganyan. So, ayusin mo yung model mo. Problema yun pagdating sa design. Anyways, kahit makaligtaan mo ngayon na may mga model na lumilipad-lipad, later on you will notice it in some part of the results, which is, for example, the displacement. Makikita mo, ba't ang laki ng displacement doon? Anong meron doon? So you will go back to that area or that place, and you will find that there is wrong connections. Okay, it seems like the displacement due to the superimposed dead loads is correct. Let's go to live load. Maybe it will have the same as well. Live loads is gravity loads. Take note, guys, that for all type of loads, dead load, live load, and superimposed dead load, they should have one direction, that is gravity loads. Okay, kaya tinatawag silang gravity loads kasi they are on the direction of the gravity. Here you will find the displacement of seismic 1/6. This is out of 6 directions. You will have this part over here. So ito yung importante na. Ito yung tinatawag nating lateral loads. Lateral loads in the sense na the movement will be lateral. This is another one. Usually, pagdating sa seismic, you will have the first two are both the major directions, X and Y. Okay, in this X and Y. And then the third, if I'm not mistaken, is somehow like a torsional movement. Oops, I think I'm wrong. Horizontal pa din siya. So, I think that is on the mode cases. Meron kasi tayong mode case eh. If you want to go on the different modal cases, you should go here on this icon. You press this icon over here. Ito, and then you go on modes. Ito yung mode 1, mode 2, mode 3. Yung mode 1 and mode 2, ito yung para sa horizontal major directions, and the mode 3 will have its twisting effect. Like if I'm gonna run this, you will have like twisting effect of the buildings. So makikita nyo magtitwist siya. Okay, this is a bit advanced. So anyway, you don't need to know all of these things. The most important part is you should know that your model is accurate, that all your connections are correct. And after that, if everything is okay, then you should go further to design. But there are some other checks also that you need to do, but I don't know if I can finish now, if it's okay to present to you now the different checks for you to be able to ensure that your building, that your model is correct. Sir Renato?
I think we can finish.
I can do it.
Yes.
Is it okay for them?
Actually, we have 4 hours class. So,
Okay, so di pa sila napapagod
ayan
dito.
nila yan.
Sige. I will show you a very quick check, okay? So, pagdating sa structure kasi natin, meron tayong tinatawag na the sum of the, when you go here, display, show tables, ito yung pinakagamit na parte ng Etabs. When you want to know the different results, you go on the show tables. Dito sa show tables, meron tayong analysis and designs. But before we go to designs, we should check first this analysis. What are the outputs here? So we should go here on the results. On the results, you have here the different results, sub-results. And from here, you should know modal results. This is what I'm referring. The modal periods and frequencies. This is pertaining to seismic analysis. Kasi you should be able to tawag nito. So sa seismic kasi natin, we have huge frequencies and sometimes we should there's a word na magde-describe na dapat yung ating mga frequencies within the range. Okay, within the range that is allowed by the code. So model frequencies, model periods and frequencies. And from here, sa model participating mass ratios, I should give you this one first. Here, I have five modes. But very important na yung five modes natin, it should capture 90% ng ating mass ng buildings. Medyo advanced siya, but okay. It should capture 90% of the total mass of the buildings. So you can see here the 1.13 seconds, these are the frequencies, yung frequency ng structures. I hope that you know the frequency of the structure, but this is a bit advanced as I've said. So ang sasabihin ko na lang ngayon is, ito lang itatandaan nyo. Display, show tables, pumunta kayo sa model participating mass ratios. Dito, model participating mass ratios. And make sure that on your model participating mass ratio, you should get this sum ux, sum uy that is equivalent to 0.96, 0.96. So this should be 0.90 and above, okay? Other than that, you should add your more modes. Paano mag-add ng more mode analysis? As you can see here, the vertical effect is not considered because this is my previous model. But in the Philippines, you should consider as well the vertical because we have high seismic activity in the Philippines. So you should consider here also the effect of the vertical acceleration. These are both horizontal acceleration, x and y. And this is in 3D if you're considering the vertical acceleration. So medyo may mali sa analysis natin. We unlock, define. So punta tayo sa define load cases here. Dito sa response spectrum, medyo mabigat na to ng konti. But anyway, I want to discuss something which is, I can give you this PowerPoint for you to follow, but UBC kasi siya. But anyway, some of the parts will be useful. Pwede nyo gamitin. Static analysis. Yeah, I want to discuss something about static and dynamic analysis. What I'm doing right now is the dynamic analysis, but there is part of the code as well, whether you can do static analysis or dynamic analysis in your building. So it depends. May criteria naman ang code kung kailan kayo gamit ng static analysis and dynamic analysis. Siguro i-discuss ko na lang to, Sir Renato, para makabisado nila. What is it? Static analysis. I guess wala siya dito. Let's go by the code. Loading page 71, page 262. Can I go to NSCP 262? Yes, this is static analysis. So here, sinasabi sa code natin na the static lateral force procedure can be applied if your structure is blah, 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 under categories 4 and 5 of the seismic zone 2, and with the regular structures under 75 meter in height. I think pasok tayo dito kasi mababa lang yung floor natin. And we are having regular structures, so, and at the same time, not for more than 5 stories at the same time. So pasok din tayo sa criteria na yan. I think we can adapt static analysis in our case. Static analysis. Okay. So what do we have on static analysis? Fine. Static. Yung presentation ng aking kaibigan na ginamit niya before, but medyo iba yung procedure. Kasi UBC and at the same time the way how it's modeled is different. Sana yung ating static. Static design, medyo useful yun eh. Bibigay ko to sa inyo, sasend ko kay Sir Renato. This is the different load combinations from the NSCP 2010. We are using the 2015, so be careful. Dynamic analysis. Static load cases. Ito yung static analysis natin. Medyo hindi siya updated kasi 2010 pa to. Static analysis. Somehow this part over here is updated. Static analysis may be used for the following structures. This category, occupancy category, you'll find this. We are at seismic zone 2, yeah? Sir Renato? Or 4? Zone 2. I should know that. Seismic zone 2 and seismic zone 4. Seismic zone 2 is for Palawan, yeah?
I think we are in
Correct.
zone 4.
Yeah, all of the rest of, aside from Palawan, it's seismic zone 4. Only Palawan is the safest place in the Philippines when it comes to earthquake. They don't have much of seismic activities. They are exempted. So, yeah, yun ang maganda sa Palawan. Zone 2. And then regular structures under 75 meters in height with lateral force resistance provided by all structures regular or regular 4 and 5 in seismic zone 2. Totoo ba? Zone 2. So if we do static analysis on our structure, ito yung gagamitin natin. Ito yung procedure na gagamitin natin. Okay? Send ko to kay Sir Renato for your reference. But you have to go back to the NSCP code and try to read again these different provisions of the codes because it's updated. So every edition ng ating code is nag-update naman. So you have to take the latest one. Hindi naman nababago. I mean like maybe some 10% of the content of the code is nag-update. So you have to know it as well. So this is the different type of system. This is the different type of soil na ginawa natin kanina. This is you following the UBC, which you will not be using it later on na kasi gagamit na tayo ng ibang way, ng ibang code. So wind load, yeah, it's the same. Walang magbabago sa wind load. Pero nagbago na yung intensity, I think, dahil sa previous history natin when it comes to typhoons. So, mass source and yun lang. Pagdating sa checking, doon ako nag-stop pagdating sa checking. Sa checking ng ano natin, display, define, pagdating sa mass source natin, kaso dito sa load combinations ko, spec X and spec Y ang meron lang tayo. Kung mapapansin nyo dito, meron akong spec X and spec Y, spectral acceleration X. And, oh, this is wrong. This should be spec as well. Spectral acceleration X. What is spec? Ito yung in-input natin kanina. If I go here, define response spectrum, ito yung dinefine natin kanina. Ito yun. Ito yung dinefine natin kanina. I have here the ground acceleration. This is by Eurocode. We should create one for the ESC. Kasi ESC ang gagamitin natin. Here, we should define what we input in there. Spectral acceleration 1. I hope na take note ko yun kanina. Ano ba ulit to? Kanina, Sir Renato?
0.9.
0.9. And then you said that you have type D, tama?
Yes.
Yes. So this should be your graph when it comes to spectral acceleration. Makikita nyo ito, very common graph to. You will encounter this a lot of times during your studies or during the practice. Okay? This is response spectral acceleration. If you notice, the acceleration of the ground will eventually go down and asymptotic to the horizontal 0.00030. This is due to the dumping of 0.05. Dumping in a way na earthquake will just last for a couple of seconds. Tama? After that, it will stop. Okay, so that's it. So this part over here, if you do manual calculations, you will do this, some kind of calculations. The good thing about Etabs is automatically, this is just a formula. So it's part of the software. Kina-calculate niya agad 1.3334 the SDS and SD1. If you want to know more what are these SDS and SD1, you can go to the NSCP code and then read this. This is very detailed in there. What are these and these? And as well as this FA and FD, ano tong mga to. And why we consider long period transition period of 8, nandun din sa code. Okay? So, and then name this one as spec X, for example. What is this function? AISC? ASC. ASC. Okay, ASC. Click OK. Yan. Pag na-define nyo na yung response spectrum, then you go to load cases. Dito, meron kang spec X and spec Y. Actually, dito, we consider both horizontal and vertical. That's why this should be U sub 1, and this should be the scale factor, and then U sub 2, and then you should add another one. Ganito dapat to eh. Or delete this. Ginawa ko to kasi for, this model is for the Eurocode. For the Eurocode, they are neglecting the vertical accelerations kasi here in Europe, they have very minimum seismic activity. So sometimes, especially here in our place, Hungary, they are not considering the vertical accelerations kasi wala talaga silang earthquake. So meron pero konti lang. So dito sa Pilipinas, diyan sa Pilipinas, ko-consider natin yung vertical acceleration. So what is this vertical acceleration all about? It should be one part of the major directions. Like for example, U1 is for the X. Okay? Response spectrum at X plus, you need to consider 2/3 of whatever scale factor that you have on that direction. Say for example, this factor over here, I think it's I over by, this is the ratio of G over by R. G over by R, G is 9,810 divided by your R is 2.5. For this system, it should be 3924. 3924. This ratio over here, if you click this load patterns, we can have this as well, static. Yeah. Kung may gusto kayong tanungin kay Etabs, what you do is, if you have this window over here, just click F1. Yan, magpapakita dyan kung ano yung gusto nyo nalaman. Yan, sabihin naman sa inyo, may mga ano dito, may mga link na pwede nyo pasukin. Response spectrum, for example, yan, papakita nyo dyan kung ano yung response spectrum. Okay, and aside from that, yung scale. I'm not sure about this scale factor, but later on you will modify this kasi it should be distributed to the mass. So for now, we will use 3924. And what we usually put here is, following the ASCE 710, you should specify this as 2/3 of whatever the value here, 2/3 whatever the value here. But in other codes, this is like horizontal, and then 30% of that horizontal. Yun ang ginagamit sa other codes. But for the ASCE, it's 3924, which is IG over by R. Not sure if it's IG over by R. IG over by R. Yes, IG over by R. So since we consider I let's say that is 1 and 1, pero hindi 1 now. We will assume unity. And then G is 9,810 divided by R, the response, what do you call this? The R, rigid, ang tawag kasi doon. I forgot the exact term dito. Define, load patterns, seismic. Itong part dito, response modification or the behavior factor in Eurocode, for example. Then we go back and define load cases. Here, we should specify this spec X. Should be one horizontal action plus 2/3 of the vertical. So 9,810 divided by 2.5, 3924, and then times 2/3, we have 2616. Yung complicated na to, but kung gusto nyo magtyaga, magkakabisado nyo to. And all of this is like a model combination code. So what do you want about this combination? Do you want CQC? What the CQC or SRSS? SRSS means square root of the sum of the squares. Okay, like Pythagorean theorem is SRSS, square root of the sum of the squares. So these are the different way to combine the loads. Okay, is it a CQC or is it SRS? Just follow this, okay? Take it by default. Then after that, click OK. Then you go to spec Y as well. In spec Y, you need to consider here U2 naman, okay? Then you make this U3. And did I change this kanina? Hindi ata, no? This should be 2616, and later on mag-change din to kasi you will scale this so that the base here from dynamic and static should follow the provision of the code. Medyo madugo-dugo ng konti yun, pero but yeah, you will understand this kapag or it should be matayo, so be careful. It should be ASCE. Okay. So now I incorporated the vertical and horizontal accelerations, and sometimes we have spec X, Y, but let's not forget about it for this modeling. Okay. Okay pa ba kayo dyan? Okay lang?
Yes, sir.
Okay lang yan?
Okay pa
Wala
naman
pa?
po.
Yan, binibilisan ko na ng konti. Yes. Okay, so when we are done with the analysis, we go to display, show tables. From there, we have to make sure this checking. Ito yung checking natin, yung verification of the model. Kumbaga. So click model participating mass ratios, this item over here, which you will get from results. Analysis. And click OK. Here, first things first, you should arrive at more than 90% of the sum of UX and UY, which means this is the amount of mass na kinonsider sa structure when it comes to analyzing this model. Model is, this is the vibration of the structure, okay? So it should be higher than 90%. This is 96, which means that we are above 96%. But why don't we have some UZ? Let me double check. Load cases, load patterns, seismic. I did consider. Define load cases, spec X, spec Y, and I will add here, add new case, spec X, Y, add, oh, no, spec X, spec Y, add copy case, usually meron to eh, spec X, Y, this is by response spectrometer, hindi ko na-click kanina. So, ito is present sila lahat. Add, meaning may U1 ka na, may U2 pa, and may U3. Spec KSCE. Parehas lang naman to. Pero ito is 2616. And then ito is 394. Okay. Then click OK. Okay. So, lagay lang natin doon para malinis. Click OK. Display, show tables. Hope nandun na siya. Model participating mass ratios. Okay, so ganito lang. Check nyo yung sum UX, sum UY. This should be above 90%. So, okay. Yung model natin is okay. Yun lang. Yun lang yung gusto kong malaman yun doon. Display, show tables, what more? Model participating mass ratios. Ano pa ba? Structure. Story forces. Ganito kasi yung ginagawa natin. Bago tayo nagpro-proceed sa design, we should check our structure first. Kung yung stability ng structure natin, kumaga. We should check it before we go for the design. Otherwise, nagde-design tayo na hindi pala stable yung ating structures. So, we can encounter. Pero pagdating sa design naman, you will see there na bakit nag-fail yung beam na to. So, i-investigate mo tuloy. So, makikita mo. Hindi yan, makikita mo naman kung saan siya nag-fail. And then from that, may issue pala ng stability. So, you will go back to checking your stability. So, what I'm doing is I check first the stability of the structure, then I go for the design. Yun yung process. So, here, story 4 says, this is by the definition of the code that the dynamic analysis or the dynamic forces shouldn't go 85% beyond of static load, something like that. So, titingnan natin. This is how to work with the tables. Kung gusto nyo i-filter, this is just like an Excel sheet. Just click here, right-click, and then right-click, and then just choose the story. We are dealing with the ground level, so let's choose story 1. And then what combination you want to consider. Ganun lang, right-click lang. We want to consider the seismic here because we want to check the response spectrum. Plus, this is the static loadings. Plus, we have spec X and spec Y. I think we do have that one. And then these are the different, and what location do we need to consider? Of course, it's the bottom of the story. Now you get these values over here. Okay. Baliktad, no? Yung spec yung nasa taas, yung dynamic. Spec X and Y is your dynamic. S1 to S6 is your static. So, ang sinasabi doon is hindi dapat tataas yung ating static loadings ng nasa range na 85%. So, if you notice, 7152 as compared to this 7325. So, 7235 divided by 7152, ilan yan? Anong ratio yan? Pasado na ito eh. 7152. So, 1.01, pasado na. It's like 1.011%. So, yon. Maganda yung ano natin, yung result. If you want to read more about this static and dynamic, nandito rin siya. I think naka-specify siya dito. Tingnan natin kung nandito. wala siya. Saan ko ba siya mahanap para may ipakita ko sa inyo? I think sa help. Let's try static dynamic ratio para maintindihan nyo. Static dynamic ratio Etabs. This is the UBC. We're not using UBC. Oh, so UBC ang ginagamit ni Parekoy. Yeah, scaling of Bayesian in Etabs. This one, I guess. Scaling of Bayesian in Etabs. May demonstration. So pag may mga tanong kayo guys, the internet is within the palm of your hands. Nandyan lahat, makikita niya. So gamitin niyo ang internet. This is 30%. I think this is 30% from other direction. Ito yung sinasabi ko kanina. Anong code ang ginagamit? Ito yun. G over by R times I pala yung ating formula. Pag nag-input tayo doon sa scale factor, dito sa scale factor, yung ginawa ko kanina. G over by R. Anong ginagamit ni Sir? Bakit nag 30% siya? ESC, yes, response spectrum din ang ginagamit niya. 30% ang ginamit ni Sir. Pero sa practice, ang ginagamit namin is 2/3 of that. Orthogonal effects in RSA. Regular structure SRS combination. 100% from one. Ito, ang ginawa kasi dito guys is 100% from one direction plus 30% from other direction. Ito yung square root of the sum of the square root of the other effect of each direction. This is the method 1. Or we can use the method 2, square root of the sum of the squares of the effect of each direction. So, ang ginamit ko is 100% in one direction and 2/3 of the other direction. And then nag-SRSS ako. Okay? But you can use this. It's okay. 100% in X plus 30% in Y. And then vice versa, 100% in Y plus 30% in X. Explore. Mag-explore kayo dito sa part na to. Gusto ko lang malaman is the ratio. Pero nawala na tayo. Etabs. Scaling of Bayesian. Scaling of Bayesian Etabs. I hope ito na yan. I hope ito na ngayon. Spec Y. I want to know the ratio. Although I know the ratio, but I want you to know kung bakit 85%. Scaling of Bayesian, or it's ang Etabs I know is may ano siya eh. Meron siyang Etabs help. Or should I define my load cases, spec X, spec Y, modify F1 bago tayo mag-F1. Ay, ba't hindi na nagpapakita si paring F1. Okay. So, yeah, I give it as your assignment. This is scale factor kasi it shouldn't exceed 85%. From what I know, it should be like static divided by dynamic shouldn't exceed 85% of that. That's why when we do the scale factor, what we usually do is we take the ratio, and if it's more than for example, more than 0.85, then we need to multiply by whatever ratio that we get from the table. How do we do that? Display, show tables, dito, story forces, for example, story forces. Then we export this to Excel. We export it to Excel. Saan na yung Excel natin? Oh, shit. Export to Excel. Yeah. So, pag na-export mo na siya sa Excel, you should get the ratio here. For example, ratio X. Ratio X equals, um, una, ito, 7235, absolute value, 7235 all over by this, but you should take the absolute value, of course, part, absolute value. So 1.011 is more than safe. It's okay. It's very safe. Ratio X is 1.011. For example, ang lumabas dito is 2.5. For example lang 2.5. Then, ang gagawin mo if, let's say for example, ang lumabas is 2.5. Ang gagawin mo is pumunta ka dito sa Etabs. Define load cases. Load cases, nawawala tayo. Load cases. Spec X, punta ka dito sa response spectrum. And then, ang gagawin mo is multiply mo siya ng 2. Ito, multiply mo siya ng 2.5. Ang magiging new value mo is 2.5 times yung initial na value mo, 3924. Example lang huwag nung gagawin kung hindi naman more than 1. Kapag 1, it's very safe. Naglalaro siya ng 0.85 to 1. Okay? That's the value. 0.85 to 1. Pag 0.85 pa, it's okay. Huwag lang bumaba ng 0.85. There's something nung pag bumaba ng 0.85. Okay? So, if it's 1, then our model is correct. It's okay. Our initial values are correct. If, let's say, for example, 2.5, 3.5, or any value more than 1, then you should multiply your initial value. So, 2.5, wow, 9, 8, 10. Very, very, napaka-timing naman, 9, 8, 10 talaga. 2.5 times the initial value. 3924. And don't forget to multiply this as well. Kasi kung whatever the value here, then you should get the 2/3 of this value and then you apply here. Okay? Did you get my point? Medyo magulo ba? That's how we scale factor or we adjust this scale factor. Should be the main reason why we scale this is we want to distribute the ang property kasi nito is parang distributed to the mass. Medyo hindi po masyadong maintindihan ngayon, hindi nyo pa masyadong maintindihan. But as you go along with your other subjects, especially in your dynamic, I don't know if they're gonna be, this part of dynamic analysis will be covered in your curriculum. But in my case, I haven't, I think we haven't tackled this when I was in college. Nalaman ko lang siya during the practice. Sir Renato, are you still there?
Yes.
Yes. So, ayan. So, for example, okay na tayo pagdating sa shear, then okay na rin tayo pagdating sa mass, and then what are some others? Let me just take a look. Display, show tables, kung ano pa yung pwede natin i-check dito. Displacement, drift maybe. Drift, we can check for the drift. For example, the drift due to earthquake and drift due to wind is by the code again. Meron pa ba tayong time? But I can skip this one. If you want, I can skip this one because it's a little bit difficult. All you have to do is you go here on the frame results on displacement, and from displacement you will have here story drifts. Story drift, you will click this one here, and then here you will find this drift, and you have this IDL directions drift X and Y meter locations, and then you have here the drift. Should be, yeah. This is the direction. Iba na kasi yung table ngayon ng ETABS. Before, it's X and Y. But now, medyo ano na siya. Magkasama na yung X and Y. But in the drift, you have to make sure that the load combination that you are considering is only the seismic. Okay, because we are checking the seismic drift, not the wind. It's the seismic, because we have different provisions when it comes to seismic and wind drift. Meron tayong limiting values there. So this is the seismic drift. You will notice that you have drift 0.01, 0.01, 0.01. Just make sure that all of these values here, when you click this and, for example, export to Excel, again, we will have this book tree. Just make sure that all of these values here equals, you will try to maximum of this 0.021339. I think the code says that the maximum drift should be not more than, sorry, medyo mataas ang ang drift natin. 0.02 atang sinasabi sa code eh. Let's check. Dito na lang tayo. I hope nandito na. Dynamic analysis. Nag-design na siya eh. Dynamic analysis 0.2. I think 0.02. Hindi ko kasi ma-control find sa NSCP kasi ang NSCP natin is wala akong PDF file. And they are not giving PDF file actually. So, yan. Whereas sa ASCE, I don't know if there's an issue of the copyright. ASCE, pwede mo siyang i-control find kung ano yung maximum drift. But, I will open a file. And wait a minute. I think I incorporated here seismic homework 1 final. Okay, I incorporated here. This is part of our project. Comparison global Europe, hindi rin yan. I think hindi siya dito. Zero version calculate period, values of CT. No, not this one. Sorry. Tsaga-tsaga lang Tsaga-tsaga lang. Pasensya na. I think, okay. This is, yes. Yeah. Good thing is na-save ko to. This is by the ASCE code. The seismic limit when it comes to the code, this is for the storage drift. Yeah, 0.02. So our limit is 0.02, as you can see here. Again, the ASCE is the reference of the NSCP code when it comes to drift. So definitely these values will be found also in the NSCP, 0.02H. So in your Etabs, whatever the values that you will get here shouldn't exceed 0.02H. So in our case, as you notice, I took the maximum of these values over here, and we found out that there is one which is exceeding 0.02H. Where is that? 0.02, this one. Number 4, loadings along Y. This one is exceeding 0.02H as well as this one. So we have 2, which means that we somehow violated not violated, but we are not within the code, or within the range that the code provided to say that our structure is safe when it comes to seismic drift. So anong gagawin natin kapag medyo may malaki na drift sa ating structure? Then we have to lakihan yung one. We can increase the size of our elements. Say for example, column. Pwede nating lakihan yung size ng column para ma-counteract tong 0.02 na to, and it should you should come up with the value that is less than 0.02. Okay? Naintindihan yon? You have to change the sizes of your columns. Pangalawa, you can add bracing elements. Bracing elements is like to more stiffness to your structure para mas maliit yung ating movement, drift. Okay? But nagtataka ako kasi we only have very low rise building, and we have very high drift values. This is the drift at X and drift at Y, but it should be amplified as well. Kasi itong values na to is for elastic pa to eh, elastic drift. We call this as elastic drift. In the end, ang i-consider natin is the inelastic drift. Inelastic drift. Elastic drift, which is the product of the elastic drift and the response modification factor that is from the ASCE kanina. If you still remember, ASCE, the response modification factor, not the response modification factor, but the load cases. Hindi siya response modification factor, load patterns, but the deflection of amplification factor, which is 2.5. Okay? 3 pala ang consider natin ng response modification factor. Is it the same model? Okay, forget. So, ang i-multiply mo dito is the deflection modification factor, which is 2.5. This is the real inelastic deflections that we have. So we shouldn't take this over here, but here. So ang laki na ng ano natin inelastic deflections na. Bakit kaya? Kasi because of ang lit ng ating mga column sizes, mga 3.5 by 3.5, it's already huge. I don't know what's the problem with our model. But let's try to see, say for example, we pass all the drifts due to wind load and due to earthquake load. The wind load has its own limiting values as well. I think that's H all over by 500. So H all over by 500 is around 3.3 divided by 500. That's around 0. Or H all over by 500 kasi naka-incorporate na doon yung height dito sa Etabs. So 1 all over by 500. So ang lalabas dapat na ano natin is 0.002. Hindi dapat lalabas doon. So other than that, kapag tapos na, safe tayo sa drift, safe tayo sa wind, both wind and earthquakes, then what's next is you have to design your structure. Dito makikita mo na maraming babagsak sa design due to drift. Yan, i-design na ni Etabs yung ating structure. Tagal. Anong meron? What is the problem? Ano man? Yes. Why? Problem mo ba? Ayun, yun. Lumabas na siya. Okay. Aha. Why? Bumabagsak siya. Did you see the red one? The red one means failed. Kapag nag-fail siya and then you click here, right click, you will find here the summary. And then from the summary itself, you will find here the output design and it says here, shear stress due to shear force and torsion exceeds the maximum allowed. So that's the problem. Shear stress, fail siya sa shear stress and torsion. Well, the arrangement of the slab itself, you can say that medyo mataas yung loads na binubuhat na beam kasi 5 meter by 5 meter is a huge span. And without intermediate beams, mag-fail tayo talaga yung beam mo, which is, if you notice, our beam is 200 by 400, which is 5 by 5 meter is already a huge span. So all you have to do if you fail in shear is you have to increase your section, especially the width. The width plays a very important role when it comes to shear. So for example, gusto kong ipasa yung aking beam. So all I have to do is I'll go to frame section and I will increase my section. For example, I'll make it 600 by 300 maybe. Let's do this. And let's try. Again, this is just to show to you how to design the beams. In actual, iba-iba yung sizes ng ating beam. So when you want to change one size of the beam, just check that part of the beam and then apply this, whatever sizes that you want and then design. Okay? So dito, typical lahat ng beams natin for educational purposes. Then design. So design properties, make sure that you are also familiar with this view, revise preferences. This is very important. It means that you are designing by what code, ECI 318, and what seismic design category D, and all of these inputs, you've already made it earlier. All right. Utilization factor, pattern live load. Okay. Click OK. Click OK, and then design. Yun. Okay, guys. Safe na siya. Black. Black means safe. Okay? So, medyo mataas-taas din bakal na. Top reinforcement dito is 1513. 1513 divided by, for example, diameter 16, 200. So, that's around 8 diameter 16 top. Medyo mataas-taas. So, if I were the designer of this building, I would put intermediate beams kasi mataas yung ating bakal so that to support some other part of the beams. So it's either I have to put intermediate beams here. If, for example, this is like, especially kapag mall, mataas na yung loadings, what they do is they put intermediate beams here, like 1, 1, 2, 3, for example. But this is already safe, 1, 5, 1, 4. If you click one part of the beam, and then you go here, and then you go to summary, this is where you can see the report. There is no any warning, so your beam is safe. What about in other floors? Do we see some red? Red means failed. Okay, wala. So it's safe. What about columns? You can delete here your beam just to be able to see the column only, and you can delete. Okay, you will find that most of the columns failed. All right, most of the columns are failed. Taas kasi yung ano eh, seismic eh. Ito yon. Dito siya nag-fail. And the reason why it's failed is also uh, indicated here. Reinforcing required exceeds maximum allowed. What's the maximum allowed reinforcing for column? You should know that. It's what percent? Up to what percent is allowed for the column? Any idea? There's a range of the allowed reinforcement for column, remember? There's a percentage. What is it? Anyone from the group? Dito po ba sila? Anyone? Okay, the percentage should be from 1% to 8%. You can read that from the NSTP code. It's 1% to 8%. So if it exceeds the maximum allowed reinforcement, it means that you should know the ratio is like it exceeded more than 8%. So what you should do is you need to increase the size of your columns. So if you notice, I am changing the sections so that it will pass the requirements. So later on, since we do have problem when it comes to drift, for example, then while you are changing the sections, it makes as a whole, it makes your structure stiff, or it adds stiffness, which means that it gives you, or it helps somehow when it comes to the lateral drift. So kapag nakatulong na siya sa lateral drift habang pinapalaki mo yung mga section to satisfy the requirements, then at the same time you are addressing also the problem due to drift. For example, the seismic drift kanina, where it exceeded 0.02. For example, for now, the last, okay, this is the last one. I will change the column to 400 by 400, for example. Define section properties. I'll change the column now to 400 by 400. 400 by 400. And modify show rebar. I'm going to reinforce to be checked here. I'll put here 4 diameters. Why not use diameter 20, for example? 4 by 4 and reinforcement to be checked. Okay, this is the last one. Then you are free. Sir Renato.
Yes.
Yun, sa oras. Hirap, parang walang maingay eh. Parang walang ano. Ito yung mahirap sa online class. You don't have interaction with your students or with your audience. So, parang ano lang, nararamdaman ko yung
Parang,
pakiramdam
parang
ng mga
nagsasalita lang sa sarili.
yung pakiramdam ng mga professors na nag-lecture. Sometimes they repeat their own words. Sometimes sinasabi nila yung ginagawa nila kasi
Kagaya
mahirap ang
ano.
virtual audience. It's very difficult to handle virtual audience. So, okay na ba tayo? Dito tayo sa design. Malapit na. Malapit na. Right. Parang bagsak pa din. Okay. Bagsak pa din ang ating column. There must be something wrong. There must be something wrong on the inputs kasi malalaki na yung column natin eh. If you notice,
Baka
malalaki
nag-lag
na.
na yung ano?
There must be something wrong. Ito yung tinatawag natin, kailangan natin i-check yung buong structure. Kapag pakiramdam nyo is something is wrong with the section or something is wrong with the input data, for example, the loadings. So, since you have the previous model, kasi itong model na to is I use it for a different code. Since you have the previous model, what I want you to do is do the same process, but using the model that we did earlier. I want you to do the same process. If you cannot do all, it's okay, but just do what you remember and give me a feedback on the result of the structure that we've made last time. Okay? Kasi itong structure natin is nag-fill pa din siya ng column. Malaki yung column natin is 400 by 400. And the reason why it's failed may be because of the wrong inputs of the loadings. Beams, okay naman yung beams natin. Earthquake, dito sa earthquake siya nag-fail maybe. Let me check one kung bakit siya nag-fail. Joint shear ratio exceeds the limit. Joint shear ratio exceeds limit. Wait a minute, I'll do something. As far as I remember, define frame sections. The modifier here should be 0.7. So, be patient lang guys. Kunting-kunti na lang. We will finish this lecture at 1:20, Sir Renato? Is that okay?
Yes, it's okay.
Anong oras na doon?
7:11 yan.
7:11? Wow. So, 7:11. Tabi ng Mercury. Sige, design na natin. Joint shear ratio. Alright, bagsak pa din. Okay. Summary. Joint shear ratio exceeds limits. Joint shear ratio exceeds limits. Why? Why are we failing? Define section properties. Last one. Oops, did we change the section? We haven't. No. This is for beam. Let's make 500 for 500. We will put to be designed. Last one. Pag nag-fail pa to, I will check the model and I will give you feedback maybe Renato later on. Kasi checking the model takes time. Then they could start with the previous model na ginawa natin before. Then they will apply the different loadings and let us see the result. All right, so yan. So I increased the column to 500 by 500 and some of the columns are already safe, but some are still not. Wow, ang laki ng reinforcement. So it should be like mataas nga. So major ratio is 1.034. Joint ratio still exceeds. So some problem with the joint ratio. Don't know why. Some problems with the joint ratio. Anyways, whenever you design the column, the most important part is you should be paying attention with the reinforcement. It shouldn't exceed to like pangit kasi na makita mo yung column mo na sobrang madaming bakal. Although the code gives you the range from 1% to 8%, say for example, hindi pa siya na-exceed ng 8%, pero pangit na yung detailing ng column mo, then you should do some revision with your column. And at the same time, you should pattern or always update whatever changes that you make in your detailing to the model of your Etabs. Okay? And make it safe. So dito, mataas yung seismic activity, maybe. That's why we are getting a failure of columns in some parts. But other than that, let's say, for example, this one here, for 515, it's passing. But here, if you notice, sobrang malaki yung reinforcement na binibigay, which is 14,478, which means that ilang bakal yan? 14,478 divided by 314, that is for, oh shit, madaming bakal to. So what I will do next, if this, for example, this is the result of the model that I did, what I will do next is I will check not only the sections but the total, the loads applied. I will check also the different inputs on the seismic parameters, which is very important. The input in the wind load, the input of the different loads as a whole. I have to check all of those, which will take time. Okay? So, importante yan na kailangan mong i-check lahat. And another thing siguro na pwede niyong gawin to be able to check your model is you run the model and then you try to, this is what I do as well, check this part over here, but we've checked it already, the different modes and the different case, for example, dead load up to wind load. Kung may mga elements na masyadong malaki yung deflections during the animation, then there's something wrong in there on that part. So ganun lang yung gagawin yung pag-check. But since you have the different model which I've shown you on the first part of this session, I want you to continue that one kasi medyo malinis yung model na yun. This model kasi is from the model that I did from one of the project that we are doing. Just a simple project. Okay, so I hope you learned something from this video, and I want you to continue the previous model that you have and give me feedback. Kung may mga tanong kayo, you can send it to Sir Renato. And then Sir Renato will uh, tell me whatever your questions are. Stop
Okay.
sharing.
Thank you, Sir Angel. So, any further questions? If if you have none, you can formulate your questions later on. Then you can ask me within this week, so that I can uh, send it to Sir Angel.
Regarding sa question nila, they can make screenshot whatever problems they will encounter in their model and send it to you, and then from you to me, send it to me. Okay, or you can directly send it to me. I can give my email. Pwede siguro ano?
Pwede siguro.
Mhm. Saan ba yung ating Google Meet? Yes. Good. So, tanong, last question. May natutunan naman kayo sa presentation? Did you learn something from the presentation?
Sir, may tanong si... okay.
Sige, go. Go ahead.
Jason, you can ask the question.
Ang sa ESCE 710 sir,
Mhm.
sa
Yes.
Etabs kay present man ang ESCE 716 asa may mas kuan gamiton.
Okay. So, yes, very good question. Anong gagamitin? Hmm, I would suggest to use the latest one kasi the code is updating. So, you should use the recent one. Otherwise, if you use the old one, you make sure that whatever input that you make in there should be patterned to the National Structural Code of the Philippines, kung ano yung nasa atin ngayon. So, kung ano yung input ng ASCE, it should be allowed from the National Structural Code of the Philippines. But it's okay to use the old one as well, ASCE, since we are just kalilipat lang natin sa ESC. Malilipat pa lang tayo kumbaga sa ASCE pagdating sa seismic. Because before we are using the UBC 97.
You can also indicate that in your report that that you use the ASC 716 instead of 710.
Anyways, let me go on that this for a quick ano yung pagkakaiba load patterns, ASCE and ito yun, di ba? Yung tinatanong sa seismic. Define load pattern seismic. What if I use ASCE 716 instead of 710? Is that the main question, sir?
Yes sir.
We don't have here the ASC 716. You're referring to the ASC 716?
Yes, yes.
And yet in Etabs, it's ASC 710.
Yung Etabs niya is 20.
Okay. What if we use the older one? Let's say, for example, here, 705. Yun ba yung tinatanong?
He is using 716, so
Okay. Yung
yung
Etabs mo is
is
nasa
updated
version, ano na yan?
2019 yata.
19? If
Parang
I'm not
ganun.
mistaken.
Or 18. Yeah.
Okay, use the recent one, ASC 716. Kung ano yung available na pinakamataas sa Etabs, yun yung gamitin mo. Mas safe tayo doon kasi updated na yun eh. Wala naman masyadong pagbabago kasi parehas lang. For example, for you, I will go to 705, modify load, and let me check the input. Parehas lang
Hindi
naman yung
naka-share
input.
yung ano mo, screen. So,
Hindi naka-share yung screen. Okay, sige. Share natin. Wait a minute. I will make this very quick now. Very quick, no worries. Very quick. Your entire screen share. So for example, mm, you're presenting to everyone. For example, here, before it's 710, now I changed it to 705. So what is the differences between 710 and 705? If you notice, dito, parehas lang naman. Walang magbabago. So it's okay. It's okay. Whether you use the old one or the new one, but make sure that the inputs are the same. Yun ang importante. Spectral accelerations are correct. And the different inputs here is correct as well. So yun lang. Make sure na tama yung mga inputs mo. Okay? Whenever you update the code, this one goes to the default value. So you have to modify this, okay? Whenever you change it. But since hindi mo naman binago. So I will not save it. If I will not save it, then define load patterns. 710, for example. Hindi ko binago to. So 32.5. So it's still correct. Parehas lang siya. Any other question? Caesar, I would like also to acknowledge the presence of the other faculties. Is there any other faculties, Sir Renato? Si Sir ano ata?
Wala yata.
Wala, okay. I thought si Sir Jeffrey Malbas is from the faculty or student si Sir. Okay.
So I think we are finished for today. So if no further questions, again, you can ask, you can send it to me or nasend mo na ba yung email mo? Wala pa. Okay.
Yeah, I will chat my email. Okay. Nation 18.angelito@gmail.com. Okay, this is my email. If you have some questions, you can send me screenshot of your model and send it to me and specify the queries that you want to ask. Okay? Salamat sa pag-spend ng inyong time and good luck. Structural designing is very interesting and challenging at the same time.
Thank you very much, Sir Angel, for your precious time, for your technical knowledge you have shared to us, to our students. So, again, thank you. So, class, I will just give to you the other feedbacks later this week. So, regarding our project paper for our semester. Thank you very much for coming. Have a blessed day. Bye-bye.
Thank you, sir.
Thank you, sir.
Goodbye,
Sir
sir.
Angel.
Thank you, sir.
Thank you, Sir Angel.
Thank you, sir. Thank you.
Thank you, sir.
Bye, sir.